All right, guys. So believe it or not, I'm actually making this video in the hospital because it seems like baby Peyton wants to come a little bit early. So my wife and I have been here since yesterday, and he'll be coming at any point in time. So I don't exactly know when that's going to be, but still got a little bit of work to do here to get you guys ready. So trying to work on that now. If I do have to randomly stop this video in the middle because the doctor comes in, I'll do that, and then I'll just continue with another video. But I'll try to make sure everything is well labeled for you guys so you know what to look at. All right, so last video that I made, we were talking about an intro to polynomial functions. So we were talking about all the basics of these. We went through and we created a couple charts. So what I'd like to do here is begin by rewriting those charts down. So remember, there's two things that we care about when we graph these. We care about end behavior, and then we care about x-intercepts. So let's draw those two charts here, and let's make sure we have these rules down pat, and then we can use these charts to help us. So remember, with end behavior and x-intercepts, we care about multiplicity. And so when it comes to end behavior, we're talking about what's happening on either end of the graph. There's four different things that could happen. We could have a graph that's even multiplicity and positive, even multiplicity and negative, odd multiplicity and positive, and odd multiplicity and negative. And the end behavior for these, if it's even and positive, this is like x squared, that's up, up. If it's even and negative, it flips, so it's down, down. If it's odd and positive, like x cubed or y equals x, it's down, up. And if it's odd and negative, it's up and down. Okay, so there's our end behavior chart. And for x-intercepts, there's three things that can happen. Each individual factor that causes an x-intercept can either have a multiplicity of 1, it can be even, or it can be odd and greater than 1. Okay, the two things for 1 and odd and greater than 1 are fairly similar, but they're just a little bit different in terms of how they look. So if the multiplicity for that causes an x-intercept is 1, we go straight through. Okay. If the multiplicity that causes an x-intercept is even, we bounce. And if the multiplicity that causes an x-intercept is odd and greater than 1, we, instead of going straight through, we do a little bit of a squiggle through. Okay. All right, so we'll see these things come up today, and we will continue. We're going to look at a few examples here, and then you guys will have some practice. So first of all, let's talk about some graphing strategy. We did graph a couple, or I guess one, I think, in the last video. This is a pretty consistent graphing strategy that you can use across the board. So our first step is we are going to completely factor. Okay, now the one that I showed you guys the other day was already factored for us. Today we're going to need to do a little bit of factoring first. After that, we're going to plot all x-intercepts. Okay, and then we're going to identify the end behavior and draw it in. Okay, and these two steps right here kind of all go together, so I might do this in a different order, but generally it's all the same thing right there, so you can almost put that all as one step if you wanted to. And then last but not least, we're going to figure out what happens at each x-intercept. Figure out the behavior at each x-intercept. Okay, and remember, this is like a puzzle, so when you're when you get to that final x-intercept, everything should fit together, and that final piece should fit, and the graph should all flow based on your multiplicity and what you're thinking about. So let's jump into some examples here. So I'll start us out with an easier one, and then I'm going to show you three examples here. All of them are a little bit different. All right, so here's our first one. F of x equals 3x cubed minus 4x squared minus 4x. Okay, so our first step here is going to be to completely factor this. So first thing I notice here, all of these have an x. So I'm going to, I'm going to take out the x. That is going to decrease the power on each of these by 1. So I'll have 3x squared minus 4x minus 4. This thing that's remaining right here, this is a quadratic, which we've worked with plenty this year. So if my quadratic has a 3 at the front, the very first thing that I'm going to do is I'm going to put two sets of parentheses, and I'm going to put a 3x and a 3x. Okay, and then what I'd be looking for here are factors of 3 times negative 4, so that's negative 12, that add up to this middle term, which is negative 4. So two numbers that multiply to negative 12 and add to negative 4 are negative 6 and positive 2. So I'm going to go ahead and write those numbers down here. Okay, and this is not quite finished being factored yet, and this is the only time that I'm going to show this because I don't want to keep doing the same thing every time we factor a quadratic. But remember, a quadratic is factored correctly if you were to FOIL it back out or distribute it back out and get what you started with. But 3x times 3x is 9x squared. We need it to be a 3x squared. So what we're going to do is we're going to divide a 3 out of one of these sets of parentheses. Okay, so I'm going to divide a 3 out of this set of parentheses because 3 and 6 are both divisible by 3. And then after that, I will be done factoring. So 3 divided by 3 is 1, 6 divided by 3 is 2, and then this last set of parentheses is going to stay the same as 3x plus 2. So at this point, we are completely done factoring this thing. And now we can start doing some of our other stuff. So what I'm going to do next is I'm going to identify what's the multiplicity of this graph. So I'm going to start out here. This is a 1, a 1, and a 1. 1 plus 1 plus 1 is 3, and this function is positive. Now, one thing I want you guys to see, at the end, my multiplicity was 3. At the beginning of this whole thing, unfactored, we take the highest power. The highest power that we see is 3, so the multiplicity at the beginning and the end matches up. So this is odd and positive, and if something's odd and positive, my end behavior is down and up. Okay, so I've got that identified. If we want to do my x-intercepts, remember to find the x-intercepts, we take each individual factor, set them equal to 0, and solve for x. So I'm going to get x equals 0, x equals 2, and x equals negative 2/3 as I go through and solve for x if I set each one of those equal to 0. And from here, that's kind of me doing these two middle steps, except I still haven't drawn in the end behavior, so I'll do that in a second. And then after that, I can work on the rest of the graph. So let's go ahead and let's plot all of these x-intercepts. So I'm going to have one at negative 2/3. Okay, again, anytime I have just a standalone x, this is not a trick. If I set x equal to 0 and I solve for x, well, I get x equals 0. So anytime I have a standalone x, I'm going to get an x-intercept at x equals 0. Okay, and then my last one is at 2. Drawing my end behavior here, I'm down on the left, and I'm up on the right, and all of these have a multiplicity of 1. And if all of these x-intercepts have a multiplicity of 1, we're going to go straight through at each one of them. And that last piece is going to fit together because it looks like I'm going to have to go through the x-axis right there. So I'll go through, and I'm good to go. So there's my graph for this function. So I completely factored it, identified multiplicity, end behavior, and x-intercepts, plotted them, drew in the end behavior, and then figured out the behavior at each x-intercept. And we'll follow the same general strategy for all of them. Okay, next up, again, all three of these examples are a little bit different. So just trying to show you some different things that you might see. All right, so let's try this next one. We've got f of x equals negative x times 3x squared plus 7x plus 2 times 4x squared plus 5x minus 6. Okay. All right, so this one is actually partially factored for us already because it's one thing times another thing times another thing. So we're part of the way there to having this completely factored. Not quite yet, though. What you'll notice here is these are two different quadratics. And I'm going to go ahead, I'll underline these in different colors here so that we can factor them separately. But both of these last two factors, or these sets of parentheses here, both have highest term of squared, which means they're quadratics. And we're going to see if, hey, maybe we can factor these a little bit further. So let's start out with the one I've underlined in pink here. So there's a 3x at the beginning. So I'm going to put a 3x and a 3x. 3 times 2 is 6. Do this off to the side. I need two factors that multiply to 6 but add up to 7. Those would be 6 and 1. So I'm going to go plus 6 and plus 1. Okay. However, as I mentioned last time, we're going to need to divide a 3 out of here. So I can divide a 3 out of that. And when I'm finished here, I've got x plus 2 times 3x plus 1. So there's my first set of parentheses. All right, next quadratic here, two sets of parentheses. I've got a 4x and a 4x. Okay, 4 times negative 6 is negative 24. I need two numbers that multiply to negative 24 and add up to positive 5. Those are going to be positive 8 and negative 3. So I'm going to go ahead and write those down. This will be a plus 8 and a minus 3. And in this case, I'm going to need to divide a 4 out of here. And I can divide a 4 out of this first set of parentheses. So that's going to be x plus 2 times 4x minus 3. Okay, all right, this is now completely factored, but what I want you guys to notice is two of these sets of parentheses are in fact the same. So what I can do is I can rewrite this as, if I multiply something by itself, that changes the exponent to being squared. So this is actually going to be an x plus 2 squared, but I'm going to bring everything else down with it. So this is going to be times 3x plus 1. And then this thing will come down here as a 4x minus 3, okay? At this point, this thing is completely factored. So that's always going to be your number one step, is completely factor that thing. And then from there, we can start worrying about multiplicity, in behavior, and all that good stuff. So let's go ahead and do that right now. Multiplicity, okay? This negative sign does not contribute to adding anything to the multiplicity. It is going to make my multiplicity negative, but it does not add anything on. So I got a 1 right here. So 1 plus 2 plus 1 plus 1. So that's 1, 3, 4, 5. So this multiplicity here is 5. Okay. And it is negative because of this negative out at the front. So that's odd and negative. If you look at your chart, odd and negative is up on the left and down on the right. Okay, so there's my end behavior. In terms of x-intercepts, okay, remember, anytime I have a standalone x, that's one x-intercept at 0. This would be negative 2. Subtract 1 and divide by 3. That would be negative 1/3. Add 3 and divide by 4. This would be 3/4. Okay, so I've got all of my x-intercepts. Go ahead and draw those in. The most negative of the numbers in that list is negative 2. Then I've got negative 1/3. Then I've got 0. And then over here somewhere, I'm going to put 3/4. So I've got all my x-intercepts mapped out. Let's draw in our in behavior. Okay, again, we're up on the left. We are down on the right. And then let's see what happens from here. So let's go through each x-intercept and let's think about the behavior. So x plus 2, this one was squared. And remember, if you go back to our chart at the beginning here, if an x-intercept has a multiplicity that is even, we are going to bounce, which we did not see on the last example. But if we bounce, that means we're going to touch the x-intercept and go back in the same direction that we came from without crossing through the x-axis. So I bounce right there. And then the rest of these all have a multiplicity of 1. So if we have a multiplicity of 1, we're going to be going straight through. So straight through, and last but not least, we will go straight through. Okay, so we bounced at one of them, that was even, and then the rest of them, we went straight through at each one of these x-intercepts. Okay, so we had to factor a couple quadratics on this one, but we got to our final answer after factoring both of these quadratics. And remember, if the same factor shows up twice, as was the case on this one, we can rewrite the exponent on that as squared. All right, one more to show you guys, and then we will be finished with this video and you guys will have some practice. All right, I'm going to make a little note before we do this example. Okay, this is a big thing when it comes to these graphs right here. So note, if the leading coefficient, I apologize for the beeping in the background here, all is well, I promise. If the leading coefficient is negative, take out the negative. Okay, and as you can maybe guess, in this next example, the leading coefficient will be negative. Okay, so if we see a negative at the beginning, the very first thing we're going to want to do is take out that negative. So let's try this. Let's go y equals negative 3x cubed plus 32 plus 48x minus 2x squared. Okay. All right, first things first, before you even think about factoring at all, put it in standard form. This is not currently in standard form. So I'm going to rearrange this a little bit. This will be negative 3x cubed minus 2x squared. We're going to put this in decreasing order of the exponents, plus 48x plus 32. Okay, and then what you'll notice here is, hey, this leading coefficient is in fact negative. So I'm going to take out that negative, and what does taking out a negative do? It flips the signs on everything. So this is now going to be positive 3x cubed, positive 2x squared, negative 48x, and a negative 32. All right, take a glance at this. What's different on this one compared to the first couple that we did? Well, this does not have a quadratic. This has 4 terms, and anytime I have an even number of terms, I should attempt to factor by grouping. So I'm going to try to do that here. Now this negative, it's just going to chill on the outside here. And if you just want to put that negative and then a big set of even brackets and then do the grouping on the inside of those brackets, you can. So that's what I'm going to try. So let's look at these first two terms, 3x cubed and 2x squared. Well, 3 and 2 I can't do anything with, but between an x cubed and an x squared, I can take out an x squared. Okay, so let's figure out what happens when I do that. When I take out that x squared, this becomes a 3x plus 2 left over. Okay, and then remember, when you factor by grouping, the very next thing you're always going to do is you're going to take out this sign, whatever it is. If it's a plus, take out a plus. If it's a minus, take out a minus. In this case, I'm taking out a negative. And then I have a 48x and a 32. Well, between those, I can take out a 16. That is the largest factor in common between those. But really what I did here was I took out a negative 16. So remember, if I take out a negative, it changes all the signs. 48 divided by 16 is 3x. And then negative 32 divided by negative 16 is a positive 2. Remember, what we're looking for in grouping is the same thing in both sets of parentheses, which I have here. This is kind of like, do side note, cool pen. If I had x squared times a minus 16 times a, and I said, what do both of these have in common? Without hesitation, I think most of you guys would say, hey, you could take an a out of there. And if I took out that a, there would be an x squared minus 16 left over. Okay, if that's true, well, then guess what? Right here, these both have a 3x plus 2 left over, or in common. Okay, so what I'm going to do here is make sure you don't lose track of this negative. Okay, I'm going to take out that 3x plus 2 that they have in common. Okay, so if I take out that 3x plus 2, what's left over is x squared minus 16. Okay, this is almost completely factored. The only other thing I can do at this point is take a look at this x squared minus 16. I'm going to write down everything that I have so far. Negative 3x plus 2. And then I have this x squared minus 16. This is a difference of squares, okay, which we've learned. There's a pattern to this. We use conjugates. To get x squared, we square x. To get 16, we square 4. And one set of parentheses gets a plus, and the other one gets a minus. Okay, and at this point, I am finished factoring this function, and now I'm going to worry about multiplicity in behavior and all that good stuff. Okay, so let's start out with multiplicity. So this negative does not add to the multiplicity. It does make the multiplicity negative, but it does not add to the multiplicity. Instead, we just think about what are the exponents on all of these. 1, 1, and 1. 1 plus 1 plus 1 is 3. And guess what? At the very beginning, the highest power we saw was 3. So that matches up. Whatever you started with, you should have the same multiplicity at the end. So once again, this is odd and negative. Okay, so odd and negative is, just like the last example, up on the left and down on the right. Okay, x-intercepts. This negative does not add an extra x-intercept, only if it has an x attached to it. The only thing I'm looking at here for x-intercepts are here, here, and here. So let's write those down. Okay, first one there, subtract 2, divide by 3. Next one, subtract 4. Next one, add 4. Okay, so I'm going to get 3 x-intercepts. Let's plot them real quick, and then let's draw them in. So I've got one at negative 4. I've got one at negative 2/3. And then I've got another one at positive 4. And if I'm drawing in my end behavior, I'm up on the left and down on the right. Okay, and all of these have a multiplicity of 1. And if they all have a multiplicity of 1, I'm going to go straight through at each one. So pretty simple graph right here. Okay, so straight through, and straight through. and all the pieces fit together, and I've got my final graph. Okay. All right. So all in all, this gives you a variety of examples of different types of factoring and graphing, and there's some practice. I'll put the answers to that worksheet practice in the OneNote folder here, and you can find that worksheet attached in the Google Doc. Hope everything's going well, guys. I miss y'all, and Merry Christmas, since it's I'm recording this a couple days before Christmas, and I will see you guys when I get back. Bye.